Hi everyone, welcome to the brave new world of learning by video. Today we are going to talk about ratios and proportions. So this is section 10.1. So the first thing you need to know is what a ratio is. So most of you are probably used to thinking of a ratio as a fraction. But all a ratio is it's a comparison of two numbers using division. A lot of times we write it as a fraction, A over B. Most commonly you'll see it as something like miles per hour. So 60 miles per 1 hour. But you may also see it written with a colon as A to B. For example, you might see something like a 3-to-1 mixture of water and frozen orange juice. So if you ever buy the orange juice that comes frozen from the grocery store, it will tell you to put the 1 can of the frozen juice into a pitcher and mixed it with 3 cans of water. So 3 parts water with 1 part orange juice is a 3-to-1 mixture. The next word you need to know is proportion. So the cool thing about a video is I can pause it while I write the definition and then start it again, and you don't have to wait for me to write. So I'll be right back. A proportion is an equation that sets two ratios equal to each other. So, for example, it would tell you that A over B is equal to C over D. And we can use them to help us find unknown quantities. For example, if you know that 60 miles can be traveled in 1 hour, that can help you figure out how long it would take you to go 450 miles, because you could set up the proportion 60 miles per 1 hour equals 450 miles per X hours. That would be one example of how you would use a proportion. We need to learn how to solve proportions. You probably have done this before. We use a technique called cross multiplication, or the cross product property. The cross product property says this: if A over B equals C over D, then you can do this. A times D equals B times C. So you multiply diagonally across the equal sign. It only works if there's an equal sign between the two fractions. This is not the technique you use if you're multiplying A over B times C over D. It's the technique you use when the two fractions are equal to each other. Let's try this on some proportions down here. First one is 15 over 9 equals 10 over X. First step would be multiply across here. 15x equals 9 times 10, which is 90. Then you need to get the x by itself, so divide both sides by 15. 90 divided by 15 is 6. And there you have it. Please show at least that much work on your homework. Here we go, another one. 10 times A is 10A. 7 times 4 is 28. Divide by 10. And this is going to give you not a whole number. I am okay with either a fraction or a decimal here. Dividing by 10, it's really easy to get a decimal. 28 divided by 10 would be 2.8. If you wanted to give a simplified fraction here, those would both be divided by 2, and you would get 14 over 5. Either one of those would be acceptable answers. Next one, we get 6 times m equals 9 times 3 is 27. Divide both by 6. Again, you do not get a whole number. 27 divided by 6, they can both be divided by 3. That would give you 9 halves, or 4.5. A little later on, I will show you some good calculator options if you're using a computer, but I know most of you are using your phones. This problem, we get 7 times k equals 8 times 10 is 80. Divided by 7. That's going to be a really ugly decimal. It doesn't simplify as a fraction. Nothing besides 1 goes into both of those. If you are going to get a decimal here, that's about 11.4. Nearest tenth will be fine on this. The next several problems, you need to be very careful when you cross multiply. Picture the x minus 1 as being in parentheses. So as you multiply across, the entire bottom of that fraction, not just the x, but also the minus 1, needs to be multiplied by the 4. So you're not just doing 4x minus 1, you're doing 4 times x is 4x, and 4 times negative 1 is minus 4. So make sure the 4 gets multiplied by both the x and the minus 1. And that would be equal to 2 times 8, which is 16. So make sure it's not just 4x minus 1. The 4 has to be multiplied by the x and the minus 1. This gives you a two-step equation. So add 4 to both sides. You get 4x equals 20. Divide both sides by 4. 20 divided by 4 is 5. Same thing on this one. Make sure you multiply both the k and the 5 by 3. So it's not 3k plus 5 equals 12. It's 3k plus 15 equals 12. Be really careful with that. Subtract 15 from both sides, and you'll get 3k equals negative 3. Divide both sides by 3, and you get k as negative 1. This one we're doing 5 times that whole thing. 5 times 2k plus 5 in parentheses equals 8 times 3 is 24. So 5 times 2k is 10k. 5 times 5 is 25. That equals 24. Subtract 25 from both sides, and you get 10k equals negative 1. Divide both sides by 10. That either can be left as negative 1/10, or you can write it as negative 0.1. And the last one here before we get to the story problems. You have 2 times that entire thing, 3x plus 2, equals 4 times 9 is 36. 2 times 3x is 6x. 2 times 2 is 4. Equals 36. Subtract 4 from both sides. You get 6x equals 32. Divide by 6. As a fraction, those can both be divided by 2. You get 16/3. Or if you wanted a decimal, 32 divided by 6 is 5.33. If you have a repeating decimal like that, put the little bar on top to show me that it is repeating. The reason that proportions are used is to solve problems where you are dealing with rates. So for example, you might be dealing with an exchange rate of money. They are also used when you're dealing with scales on maps or models, or you're dealing with something like a photograph and a actual situation. So let's look at the first one. We've got money in Western Samoa. I'm not sure if I'm pronouncing this right. I'm sorry to those of you that know how. I'm assuming this is called the tala. So the exchange rate is 17 tala to $6. So I can make a ratio out of that. 17 tala per $6. Now I want to know how many dollars I would get if I exchanged 51 tala. So I can set up another ratio. Tala need to be on top. And I want to know how many dollars. So the same units should be on top in each ratio, and the same units should be on bottom. So I have tala on top of both fractions, and I have dollars on the bottom of both fractions. And then I could go ahead and cross multiply. So 17 times x equals 51 times 6. 306. Divide by 17. And you get 18. Make sure that you have units for story problems. $18. So the next one, we have a model satellite. I have absolutely no idea what a satellite looks like, so I'm not going to attempt to draw it. But we have a model satellite, and it has a scale of 3 centimeters to 2 meters. So what that means is that on the model, a part that is 3 centimeters long would correspond to a part that is 2 meters long on the real satellite. So if the model satellite is 24 centimeters wide, how wide is the real satellite? So I'm going to write this scale factor. That's what this is called. I'm going to write this as a fraction. 3 centimeters on the model corresponds to 2 meters on the real satellite. So I have model over real. is the form my fraction's taking. That will equal 24 centimeters on the model over x. And notice that I'm measuring the real satellite in meters. If I cross multiply here, I get 3x equals 2 times 24 is 48. Divide by 3. And I get x equals 16 meters. Be careful of units. Make sure you're thinking about, okay, the model satellite was measured in centimeters, the real satellite is measured in meters. And make sure you're thinking about which one goes on top of the fraction, which one goes on bottom of the fraction. And you can easily set these up. Now this problem, it is really not fair that you guys are not here because I usually call on someone to come and be my artist. My art skills are, well, there's a reason that I am not teaching art. I will just let you sit here and admire the beauty. That is a baby giraffe. Yes, I know. It's obvious that that's what it's supposed to be. My artistic skills are astounding. So this is why I generally call on someone to be my artist, because, yes, this is why. Okay. So we have this baby giraffe who for some reason is standing by this flagpole, because obviously that's where baby giraffes hang out, is by flagpoles. And the baby giraffe's shadow is 25.5 feet long. Now the flagpole is 17.4 feet tall, and this flagpole's shadow is 76.6 feet long. So the sun's up here somewhere. It's a blue sun. I don't know why. Just go with it. So we want to find out how tall the baby giraffe is. It's a tiny alien baby giraffe. The last time I drew one, it looked more like a llama, so we'll just go with it. So I need to set up a proportion here. So I will go with height of the giraffe over height of the flagpole. So I have gone with object over shadow. And, oh no, wait, I have gone with, sorry, giraffe over flagpole. And that is going to be equal to 25.5 over 76.6. So this right here is the object, and this right here is the shadow. So make sure the two numbers on top match up somehow, the two numbers on bottom match up somehow, the two numbers in each fraction match up somehow. So the two numbers on top are both from the giraffe, the two numbers on bottom are both from the flagpole, the two numbers in this fraction are both from the physical object, and the two numbers in this fraction are both from the shadow. So if I cross multiply, I get 76.6x equals 17.4 times 25.5. That's 443.7. Divide by 76.6. And you get x equals 5.8 feet. Now this is not the only way I could have set this up. I could have set this up in a lot of different ways. I could have set this up as x over 25.5 equals 17.4 over 76.6. Then I would have been doing giraffe over giraffe, object over shadow. With giraffe and flagpole. So there are a lot of different options. You can try a couple of different things. If you end up with something other than 5.8 feet, your arrangement doesn't work. But there are several different ways of setting this up so the problem works. Just make sure the two numbers on top are corresponding to each other, the two numbers on bottom correspond to each other, and the two numbers in each fraction correspond to each other.